Hello and welcome to Otten Math. In this edition of Otten Math, we're going to take on some practice problems involving solving linear systems by graphing and solving linear systems algebraically. Right, let's get started. We've just got a couple problems to do. First one is, the first two, we're going to determine whether the ordered pair is a solution of the system. Right, so what we want to do is we want to take the values of -3 and 1 and determine whether or not they satisfy the requirements of both equations that are listed. So I have -3 for x, so -3 plus 1 for y is equal to -2. And I can see that that's correct. -3 plus 1 is equal to -2. Then I substitute again in the second equation, -3 for x, and I have 2 times -3 minus 2 times 1 is equal to -8. So I can say this is -6 minus 2, that's equal to -8. So -3, 1 is a solution of the system. Now there could be other solutions if these are two lines that are the same line, but at least we know that -3, 1 is a solution of the two systems. All right, let's take number 2. I'm going to substitute in 2 for x here in the first equation. 2 times 2 plus -4 is equal to 0. And I see that 4 plus -4 is equal to 0 is true. So this first equation is true. And then I substitute 2 in for x and -4 in for y in the second equation. And I have -2 plus 2 times -4 is equal to 10. So that gives me -2 plus -8 is equal to 10. And I see that that is not true. So 2, -4 is a solution for the first equation, but not for the second, which means that it's not a solution of the system. It's a solution for this one equation, but in order to be a solution for the system, it has to satisfy or make true both statements for both equations. All right, moving on. Problem number 3. We're going to determine whether the system is consistent and dependent, consistent and independent, or inconsistent. All right, so the first thing we need to figure out is whether or not the system has a solution that's just one variable or one ordered pair. And we see that it does. And then we also see that these two lines are independent of each other. It means they're two independent lines. So we're going to say that it's consistent because there is a point of intersection. And then we're going to say that they're independent because they're two different lines. So we're going to say it's consistent and independent. Now if I had two parallel lines, they would be inconsistent because they would never intersect. And if I had two lines that were the same line, then it would be consistent and dependent. All right, last problem. We want to graph the system, then determine the solution of the system algebraically. Okay, so let's rewrite both equations as y is equal to mx plus b. The first equation, we just subtract 2x from both sides, and we have y is equal to -2x plus 1. So our y-intercept is going to be just 0, 1, and we know the slope is going to be -2. So for every 2 units down, we go 1 over. So it's going to look, here's going to be a point here, and here's a point here, and if we run a line through these 2 points, or 3 points, we have something that looks like this. And then we rewrite the second equation as in the form y is equal to mx plus b. And we have y is equal to -x plus 2. And we're going to use red for this one. So we have plus 2, 0, 2 is the y-intercept. The slope is going to be -1. So we know for every 1 unit down, we move 1 unit over. So if we plot this out, it's going to look something like this. We connect these 3 points, and we see that there is a point of intersection. Let's find out where that's going to be. So again, we solve for one variable in terms of another, and we've already done that for y is equal to -2x plus 1. So we can set these two equations equal to each other. If y is equal to -2x plus 1 and y is equal to -x plus 2, then we know -2x plus 1 is equal to -x plus 2. So I'm going to add x to both sides, and I have -x plus 1 is equal to 2. and I'm going to subtract 1 from both sides, and I have negative x is equal to 1. And then I'm going to divide by negative 1, and I can say x is equal to negative 1. Well, if x is equal to negative 1, step number 3 is to solve for the second variable, y, by substituting in the value of negative 1 for x. So let's take the second equation. Y is equal to negative 1 plus 2. So y is equal to 1 plus 2. Y is equal to 3. So my ordered pair solution is going to be negative 1, 3. That's it for Otten Math and the first section of Chapter 3. Come and join us for Chapter 3.2 and a lesson, again, about systems of equations.